talk about database management systems. In this lesson, we will talk about database systems, the functions and components of a database management system, master data management, databases and normalization, entity relationship diagram and relational modeling, and enterprise content management, or ECM. Imagine a small business owner managing a coffee shop. Imagine that person keeping track of all the transactions using a normal spiral notebook. Imagine him or her keeping track of all the items in the menu along with their corresponding prices using that notebook too. It's a bit difficult, isn't it? What if that person becomes a bit more tech-oriented and uses spreadsheets in the computer to keep track of those things? It would make life a bit easier. But what if you suggest using a database management system or a DBMS specifically designed for the transactions in the shop? It would definitely make managing for that person so much more of a breeze. What is a database? In computer terms, it is a collection of data. Typically, it is the data of one specific enterprise. A database, as you may have experienced, is not necessarily always stored in a computer. Records stored in a filing cabinet, in a notebook, or whatnot can be considered a database. But often, this manual method of storing information is not as efficient as using a computer. Going back to our coffee shop example, it is true that we could use spreadsheets or different documents and folders in our computer to keep track of things like what's included in the menu, what are the inventory of supplies and ingredients, what are the cash inflow and outflow, and so many other things. But often it is more advisable to use a database management system or DBMS. So what is a DBMS? A DBMS is a collection of interrelated data plus the software and hardware used to access the data in a useful manner. A DBMS is a database or a set of databases stored in a disk or other media, a computer or a set of computers where the software to access the data can run. Let's dig deeper into the functions and components of a database management system. The DBMS should first provide a convenient and efficient interface for storing, retrieving, and updating data. It should also provide a convenient and efficient interface for extracting useful information from the database. It also provides a clear and logical view of the process that manipulates data. Take note of the words convenient, efficient, clear, and logical. Aside from those main functions, a DBMS also has the following functionalities. Data independence. It maintains the segregation between the program and the data. Concurrency control, and this answers the question to what happens when more than one person is accessing the data. Recovery services. What if the system crashes and the data is apparently lost? Utility services. A DBMS also performs initialization and maintenance operations on a database. So then, this is what makes up a database system. A database system has the following components: the users, the database application, DBMS, and the database. Let's talk about the users. The users of a database system are the database administrator, system developer, and end user. A database administrator, or DBA, is the person responsible for all the data resources in an organization. The DBA uses tools that come with a DBMS to improve the productivity and performance of database planning and design. The system developers are those group of people who create the application programs that cater to the user requirements. And they use their own tools to write programs that communicate with the DBMS. Finally, the end users in an organization are the ones that can add, update, and delete data in a database through application programs or directly through a DBMS. They use the application program to accomplish their day-to-day tasks. The next component of a database system is the database application. This is a computer program that allows users to manipulate the data in a DBMS through a user-friendly interface. It can be divided into 4 broad categories. Personal, which is restricted to a single user. Departmental, which is referenced by hundreds of users over a shared system or network. Enterprise, which extensions of departmental applications involving thousands of users. And the Internet, which is the largest form of information sharing where billions of users are involved. The next component is the DBMS. And we have already dug a bit into what DBMSs are. But when it comes into the grand scheme of database systems, you should take note of the following. The DBMS decouples application programs from data. The databases store all the data in one location and thereby limiting data duplication. And examples of DBMS include Access, Oracle, IBM's DB2, and SQL Server. The final component of the database system is the database itself. This is the space in the disk or computer where the data are actually stored. Let's now talk about master data management. For large companies or businesses dealing with a huge amount of data, it may be difficult to make sure that these data are consistent and synchronized across every system. One department may input data for a customer differently, or one detail about the customer can change in one department but is not updated in other departments. The company needs master data management to handle these. Master data is one single point of reference for every unique entity in the business. Master data management ensures everything in the business makes use of that single point of reference. The goal of master data management is to provide synchronization to the most critical pieces of data. It establishes rules, criteria, and details attached to the data. And having master data management couple those things to the data allow every single system using the data use it in the same way. Master data management has 5 core functions: content, relationship, security and access, change management, and processing. When we talk about content, an MDM gives rules on how the data is represented as it must be consistent in all systems. In terms of relationship, there must be a consistent definition of relationship and groupings. As for security and access, an MDM defines who has the authority to read and write to a data. Change management is when one's data changes, how do we let others know that the data must be changed or has been changed? As for processing, this is what makes master data management an MDM. It integrates the first 4 functions together and executes them. How do we now start visualizing what should go into our databases? Our database will be composed of records, which are in turn composed of fields. Records are individual items that go into the database. In our coffee shop example, these are examples of records. A record containing a menu item, CL1, cafe latte, hot drink, 100 pesos, espresso, milk sugar, CM2, mocha, hot drink, 110 pesos, espresso, milk, chocolate, sugar, IA1, iced Americano, cold drink, 90 pesos, espresso and water. And so, for those records, the fields would be item code or number, the item name, the item type, the price, and the ingredients. Another record would be a record containing the customer who brought the item. So we can have 000424 Juan Luis and 000425 Maria Mendoza. And these are the fields for these records, the customer number and customer name. This is how the records will look like if they are arranged in a table stored in the database. Each record becomes a row entry and each field becomes a column in the table. We need to make sure that each table has a field which is a primary key, which identifies each record as unique. Once you have identified what records should go into the system, you can then start to create a design for the database. The design should be normalized. There are several levels of normalization. First normal form, second normal form, third normal form, Boyce and Codd normal form or BCNF, fourth normal form, and even fifth normal form. We normalize in order to reduce data redundancy and improve data integrity. Normalizing until third normal form will be enough. These are the rules of first normal form. Number 1, each table cell can contain only one value. Number 2, each record must be unique. Let's convert our previous example into first normal form. We don't have any problems with customer, but we do have some problems with menu item. So here, we can see that the ingredients have multiple entries per cell. And what we have to do is that we have to separate those ingredients and create a row for each separate ingredient with the fields being the same as its previous fields. These are then the rules for second normal form. Number 1, the primary key consists of only one field, or 2, non-key field attributes exist in the table, or every non-key field attribute is functionally dependent on the full set of primary key attributes. So if either one of those 3 rules are fulfilled, then it can already be considered second normal form. Let's convert our previous example into second normal form. So here, the ingredients will be brought into a separate table. So now our menu item satisfies rule number 1 and menu item ingredient satisfies rule number 2. And here the primary key is the item code and ingredients. Now let us move on to third normal form. These are the rules of third normal form. First of all, it must be in second normal form, and secondly, there are no transitive dependencies. We define a transitive dependency this way. A is functionally dependent on B, and B is functionally dependent on C. In this case, C is transitively dependent on A via B. Let's convert our previous example into second normal form. We can see here that the item type causes a problem, as changing, let's say, the item name will inadvertently change the item type as well. So we must bring out the item type and create a separate table for it and make sure that we have primary keys such as item codes to correspond to the item type. And so now here we have the tables converted into third normal form. Okay, let's head on to entity relationship diagrams and relational modeling so that we can see how a DBMS evolves from an abstract concept into something more conceptual, or at least something that we can visualize a bit more. Most DBMS packages for microcomputers make use of the relational data model, as it has been widely used since the 80s. The other models that were previously used were the hierarchical model and the network model, but these have many drawbacks. In addition, these two are only usually found in older mainframe and microcomputer systems. So relational modeling it is. Relational models highlight the relationship between records or entities in a database. We know what records are, but what are entities? Entities are the representation we use to contain information on one real-world person, object, place, etc. Our normalized tables usually correspond to our entities here. And entities includes attributes that describe the entity. In our previous exercises, the attributes are actually the fields we use as table columns. Entities have relationships with one another. Relationships can also have their own attributes. These, the entities, their attributes, and relationships are what we store in a database that uses the relational model. Let's go back to our coffee shop example. What are our entities? Here are some of the entities that we can consider from the normalized table. The menu item ingredient, menu type, customer. And we will add an additional entity, which is order, because we realize that we will need an entity for the orders too. Entities are represented by rectangles. And so these are how our entities would look like in the entity relationship diagram. Let's enumerate some of the attributes. For the menu item, we can have the item code, item name, the menu type ID, which is a foreign key referencing to the menu type number, and the item price. For the menu item ingredient, which was initially a multi-valued attribute but become a separate table in our normalization, we have item code and ingredient names. For menu type, which aside from being derived from the third normal form, you can actually reference the menu type in the menu item to this entity since you already have a fixed set of menu types. So the attributes are menu type number and menu type. As for the customer, well, the attributes are customer number and customer name. And if you have loyalty points but otherwise, the customer name might not be necessary. As for the order, for this example, let's keep things simple and simply include the order date. Attributes are represented by ovals, and these are some important types of attributes. The primary key, which is an attribute used to identify each entity uniquely. We draw the oval and have the name underlined. Multi-valued attribute. If the attribute has more than one value, for example, ingredients for menu item, we draw this with ovals with double lines. As for derived attributes, well, there are some attributes that are not stored but can easily be computed. Let's say menu item might have an attribute called subtotal. We compute it by multiplying the price with a quantity. And derived attributes are drawn with dotted lines. These are the illustrations for the examples of these attributes. What about the relationships? We have several relationships in this diagram. So we can have a relationship called places. A customer places order. One customer can place many orders. We have the relationship contains. The order contains the menu item. And many orders can actually contain many menu items. We have another relationship, belongs to. The menu item belongs to a menu type. One menu item has one menu type. And we have the relationship has. Menu item has menu item ingredient. Many menu items can have many ingredients. Note that there are several cardinalities for a relationship, and these are the one-to-one, one-to-many, many-to-many. And let's see how these relationships and cardinalities are represented in the first three relationships mentioned. Our entity relationship diagram now looks something like this. We can see how all the entities, the attributes, and their relationships, along with the cardinalities, come together into one diagram. I will briefly discuss some more advanced ERD concepts. We have weak entities and weak relationships. A weak entity is an entity that depends on the existence of another entity. In our ERD, order is actually a weak entity. Weak entities use a foreign key from the strong entity and its own attribute to form its primary key. In this example, the primary key is the customer ID coupled with the order date. We can also have recursive relationships. For example, we have an entity employee and a relationship supervises. An employee can supervise another employee, right? We do not need to create another entity supervisor because the supervisor has all the attributes of an employee too. And let's see how we represent these ERD concepts. Now we know how our data in our database relates to one another. Our ERD will also help us create or define more detailed tables for our database. Now, how can we manage content which cannot be easily stored or converted to a data in a database? This is where enterprise content management comes in. Enterprise content management is defined as the strategies, methods, tools used to capture, manage, access, integrate, measure, and store information. Here are some key points about enterprise content management. Key point number 1, ECM manages different documents or files, which are the content. It makes sure that businesses can deliver right content to the right people at the right time. So here, metadata is attached to the content so that it can easily be searched for in the ECM and you don't have to search through individual documents. Key point number 2, workflow automation. Manual processes can be automated and electronically executed through the ECM. Key point number 3, has enterprise applicability. So it can start in one department and it can be extended to other departments too. And key point number 4, security. Individuals can only interact with content they have permissions to. An audit trail is attached to each content to see who did what to what. And there are actually many ECM softwares available in the market. Your turn. What businesses are you involved in or have tied up with? Will they benefit from using a database management system? Identify what DBMS should be useful for this business. If there are many, list them down too. Do you think the databases should be unified or should they try to run separately? Now list down what records do you think the DBMSs should contain and create an ERD for each database.